scratching wafers or depositing a funny pattern on the wafer. So because the SBC chart went out, and then you can take a look at the other things that we have, like the picture of the wafer, and a technician can go, oh, it looks like this is scratching it, or it could be coming from the tools that I used to work on. We used to have gases and RF, and I used to work on a tungsten tool which deposited a tungsten on top of the wafer. So if you had a leak in your gas lines, or if you had your RF was messed up, or your vacuum was messed up, or you were controlling your pressures, you could see all that on the wafer because it would give you a different pattern. You could make a decision. I don't know if that answers the question.
Yeah.
We look at SPC every day.
Yeah.
Right? We look at tons of data every day, looking for trends and everything else. Because just with statistical process control, quality control is very important, because if you don't have good quality, you don't have good product. No one's going to buy our product if we can't make good quality wafers, right? It's the most expensive thing when it comes to production is good quality, right? So the better your yield is, so you have die yield and line yield. Line yield is when you scrap wafers, you just throw them out, right? Die yield is you don't scrap a wafer, you ink the die to scrap that specific die, you don't use it, right? You want 100% yield all the time, you don't get that, right? So it's just very expensive, and we always constantly looking at trends. We pay people to look at charts 24/7 to make sure that the line is running the way it should. And there's always something going on where someone is not following a documented procedure, right? And they may make a mistake, right? Or they may not be documented, right? Where we have to write a procedure to make it documented so people can follow that, so prevent them making mistakes. Documentation is very important. Following procedures is very important, because you could lose thousands and thousands of dollars, scrapping, having multiple scrap events. And fortunately enough, we're not in the process side, we're on the automation side, but we do scrap wafers every once in a while for some mistakes. So.
And at the rate this stuff runs, it runs so fast that's why we qualify it so often. And then also, you're concerned with particles in your yield, because the line widths we're dealing with, you can ruin tons of chips by getting just one particle on the wafer.
So we're going to cruise through this because we're running out of time. I'm going to talk to you guys, for a very long time about the manufacturing industry. But basically, what we're making products for is what you see down here, right? The mobile market's very, very huge. That's what we do. From sand to silicon, all the way down into your iPads and phones.
I think we just built a chip for a video card, so for your PC gamers. we built the chip for AMD video.
But we don't have any. No, these guys don't like games.
Yeah, I didn't think so.
That's old.
So you can see here, right, down to 3D circuitry. This is what it would look like, right? When I was talking about lithography, making patterns and everything else, this is very, very small, right? So it's a lot of work, and again, more data, right? We got to make sure that everything is running the way it's supposed to, because one little particle, right, one mistake could scrap a die.
And just to understand this a little better, Pat showed you the flow, the process flow. So we build up. So you put a pattern down, you etch away, you fill up your etch, you put another pattern down, you just keep building up. So that's why you see these levels. So this would be like, you just keep building up to build your transistors. So it's not like a typical assembly line where something goes in and it goes in a straight line, it goes out, it goes in and it goes back and forth and back and forth and back and forth until it gets to the level it needs to be at.
So here's your transistor. You're going to be learning a lot about that in the next couple of years, and in all your classes, what a transistor is, right? And doing all the math and everything else, and this is what it really looks like, right? And a very small level. One of the questions I ask in the interview every single time: what's a transistor, right? So that's what we make. We want to make it. You'll never do anything with this but buy the product, right, and make it. But the fact is, we want to know you guys know what you're making. So. So you have your source, gate, and drain right there. Yeah, so keep on going. We're going to go through this. We're going to scroll through this. So diffusion process. This kind of breaks it down to the modules. And we have product spaces. This is where what we built for is different companies. So a company comes to us and say, hey, we want you to make a chip. We have turn away customers, right? We can't accept everybody because we don't have enough capacity for that. So we're always trying to choose the right customers, and that's always a risk as well.
And there's more to automotive too.
Yep, exactly.
Become big.
We can go through this. So basically, building a career, this talks about career at Global Foundries. Keep on going. News updates. I mean, this is very, just some more information. Continue. And go down to the next slide. We also do community volunteering, so this is pretty cool. So Brett Brittenhall, he's one of my peers that works on automation. You guys ever see these programs?
First one,
Huh? You've done that? Who else has done that?
we've actually hosted one of the competitions here at Penn College,
Great.
a couple of years, yeah.
That's awesome. And we, we're in the local areas, we donate all kinds of money. Of all the local businesses there, all tech businesses donate money for these type of events up there, and we get involved as well. So, so Brett is our lead for our site. There's a video. I know we're out of time, right? And
Yeah,
Jeff,
I think I have to get to.
I can send you this video and you can share it with everybody.
Yeah,
It's
that's
about 10 minutes long. It pretty much shows, what inside the factory looks like, and kind of goes through the same thing we talked about. But I think I'd recommend you guys watching it.
And you're looking for entry-level people with 2-year degrees minimum, right?
Yeah.
So once you get your degree, you're not looking for any experience. That's what's kind of cool about Pat coming here. Some companies, they want 3 to 5 years of experience. Well, if you just graduate, where can you go? Well, this is entry level, right? You're going to train these students, and then you have educational benefits if you want to go on for your bachelor's. I mean, Pat, you got your bachelor's, right?
No, I don't have a bachelor's yet. Still going.
Bachelor's? It looks like you're about.
On the LinkedIn, yeah.
On
So
LinkedIn.
it needs to be updated.
You're getting close.
Getting close.
Getting
Yeah.
close.
So it's
But Global Foundries or IBM paid for most of that.
yeah. So it's about $5,200 a year to
Intel.
give you.
That's what
Yep.
Intel.
So Intel, the site I was at, I can't recall what their cap was, but Global Foundries is about $5,200 a year to give you to go back to school. So you pay for your school, they just reimburse you. They just won't give it to you. But I wish they did that way. But
And as far as summer jobs, do you ever bring anybody on? the
so we
summer?
have internships, and they're for the 4-year program. So if you're you're going to your junior year, it's usually geared around the senior year.
That's a lot of companies do, yeah, the
Yeah.
last year, but.
So we do have the internship program. But the wages, I mean, it's very competitive, right? It's just like Global Foundries is very new, and it is a great opportunity. We've had kids who just started, college students who just started, right? One guy got out of college and he started January 2015. He's already interviewing for engineering positions, right? So there's just a lot of opportunity to grow in the company. It's a great company to work for to start your career. It's not a dying business. It's just the technology keeps on changing. We're going down to a different node when it comes to a 7-nanometer processing in the next couple of years. We're going to be focused on that. So, and then, like I said, most likely another factory would be built. We haven't broke ground on it yet, but the design's there. It's already submitted.
Now, in your particular job, when you started, you probably didn't do a lot of programming, you probably did
Oh,
PLC.
so what I did,
none of
at the very beginning, what I did is just I did the grunt work in the very beginning, right?
Preventive
So,
maintenance stuff.
preventive maintenance, wiping down chambers, right? Working on small projects, and that's one of the biggest things is that.
Probably a lot of stuff you learned down at Penn State, some of the.
Yeah, I mean, those were, like, when I got to Intel, I was definitely prepared well, right, to start my career. I understood how the process worked, understood what the semiconductor industry was about. So going in there, I had a head start over everybody, right? But the fact is that once you get into the business and you get a job, you own your own job, right? That's how it works in the real world, right? So it's just, you're getting all the education now and everything else. When you get into Global Foundries, yeah, there'll be programs, training programs, and everything else, but the biggest thing is you own your own job. You make your career what you want to make it, right? So depending on how far you want to go in your career, Global Foundries has a lot of great opportunities. People get promoted, right? So I spent a long time in Intel, and then I decided to become a manager, right? And now I'm down here and doing this, right? Teaching you guys about the business and that we are hiring.
So
Yeah.
the Penn State semester is probably an advantage, but it's not necessary, right?
No.
It's, if you can get down to Penn State for the end of the semester, great, get you a running start, but not necessary.
The biggest thing I think is, with the entry level, we'll interview you about your school, right? What'd you learn, right? What a transistor is, right? Because we know that you guys have just basic, you know, it's just a college background, but you just have theory of operation, and you may have some basic hands-on experience, right? Whatever you did in the lab. You might have worked on projects. I heard you say Arduino.
Yeah.
So that's one of the biggest things we talk about, is because we have a lot of colleges that focus on Arduino chips and making, and focus on their senior projects or their sophomore projects. They do a specific, have a little competition
Yeah.
with programming and building the robots and stuff, so. But good seeing you, Norman.
Yeah, see you, Norm. All right. See you guys, I guess tomorrow. Have a good day.
Guys, good luck. It was nice talking to you. Thank you for your time.
Thank you.
All right.
Thank you.